In this example, we're going to be talking about critical points. In critical points, we're going to try to figure out what that is and how do we find them. They can help us find some extrema, some maxes and mins. And so they're going to occur when we take the derivative and we set it equal to 0, or when the derivative does not exist, aka undefined. So some asymptotes potentially in the original graph. So what that does is when we have a slope, remember that a derivative is a slope. And so we have some sort of a curve, and slopes of 0 are going to create maximums potentially, minimums, but they also might be these parts of the graphs that look like this, where the graph levels off. So just because we set it equal to 0 doesn't necessarily mean, oh, we have a max, we have a min. We might have this point where it kind of starts to level off, but then it goes back up again. And then for an undefined, that's when we have the graph kind of goes vertical just for a second, right? So we have this undefined slope. All right, so those are really your four kind of scenarios that are going to happen. Most of the time, we're going to try to find these maxes and mins because we're going to maximize something or minimize something when we go to a word problem. But these occur as well. We got to kind of filter out, when do we have this situation versus when do we have this situation. So let's do one. So it says we're going to find the critical points. That's all we're looking to do. We're not going to find out if they're maxes or mins quite yet. We're just going to find critical points. It basically means we're going to take the derivative of this, set it equal to 0, and solve. So just to kind of throw this out here, this piece right here, the natural log of x does have a domain 0 to infinity. Remember that you can't log negatives and you can't log 0. So just to kind of keep that in the back of our mind as we're kind of going through things. So we're going to do the derivative of this. So if we do the derivative, we have a product rule. So we're going to do the derivative of the first. So 2x times the second plus the first times the derivative of the second. The derivative natural log is 1 over x times the derivative of the inside, which is 1. So we have a chain rule always on that. So if we do a little simplifying, we're looking at the derivative equaling 2x natural log x plus that x can cancel one of those x's, and so we would just have an x. Right, so that's our derivative, but we want to find critical points, which means we want to take this and set it equal to 0. So we're going to take this 2x natural log of x plus x and set it equal to 0 and solve. So first thing I'm going to do is I can take an x out of both. 2 natural log of x plus 1 equaling 0. We'll set this equal to 0. We'll set this equal to 0. Natural log of x plus 1 equals 0. So if we were to solve this, we're going to subtract 1 and divide by 2. So I'm looking at a natural log of x equaling a negative 1/2. And then to solve logs, we are going to exponentiate, which means we are going to make these exponents. So then when you have an exponential that has a log as an exponent with the same base, these just cancel and it just becomes whatever value is on here. So then x equals e to the negative 1/2. And then our other answer was x equaling 0. So let me just rewrite one last time on this. Is I have a 1/2, so that's a square root and a negative. So it's 1 over the square root of e. And then x equals 0. However, x equals 0 gets kicked out because it's not part of our domain. So sometimes that happens, right? And that's why we kind of bring that up at the very beginning of what kind of a domain do we have? Do we have any issues? Because one of your answers may get kicked out because of that. So that gets kicked out, not in domain. But as long as it's a positive value, we're good. And this would be a positive value. So our critical value for that equation, and I don't know what it would be, but that critical value is at x equals 1 over the square root of e. All right, so that was just finding critical values, and then eventually we're going to start finding some maxes and mins and figure out how do we know that.